Hello, today we're discussing process improvement and Six Sigma and what is Six Sigma. So first, what is a breakthrough? Basically, it's any accomplishment of any improvement that takes an organization to unprecedented levels of performance. So process improvement methodologies and tools, these things are providing foundation for breakthroughs. And we'll discuss Six Sigma approaches and what Six Sigma actually is. As we look at one organization, Iredell Statesville Schools, they have classrooms that focus on 5 key questions, which are what do students need to know, how will they learn it, how will we know they have learned it, what will we do if they have not learned it, and what will we do if they already know it. So we have this cycle, plan, do, study, and act, PDSA. It's used to identify and implement improvements in the education system. It's also used throughout the school district. It's been very successful thus far. Caterpillar Financial Services maintain a constant focus on process improvement, always looking to do things better. They use tools, and we'll discuss these too, Six Sigma, and they help the organization prioritize and manage projects better. 97% of employees are trained in Six Sigma. Investments in technology, along with focus on continuous improvement, are helping this organization be very successful. So as you look at your organizations, the ones that you're focusing on for your final projects, what are some of the things they're doing in order to be successful? Are they implementing some of these tools? Do they use them effectively? As we look at process improvement methodologies, and again, some of the things that we want to use, there's common themes that can be applied from Deming. So in terms of creative problem solving and processes of Six Sigma. So redefining and analyzing the problem, generating ideas, evaluating and selecting ideas, and implementing ideas. These are part of the Deming cycle. Now, redefining and analyzing the problem, here you're collecting and organizing information, analyzing data, the assumptions that go with them, re-examining problems for new perspectives, a different way of looking at things. And you have the goal of achieving a workable problem definition. Generating ideas, the idea of brainstorming. You want to come up with various solutions to a possible problem. Evaluating and selecting ideas. Again, which idea is going to be the best? Implementing ideas. Coming up with or selling the solution, getting acceptance by those who must use them. So the Deming cycle, basically it's an adaptation of the scientific method for process improvement. Now, in 1939, Walter Shewhart first introduced this as a 3-step process of specification, production, and inspection for mass production, which constitutes a dynamic scientific process for acquiring knowledge. The Deming wheel, as we look at here, consisted of designing the product with appropriate tests, making the product and testing in the production line and in the laboratory, selling the product, testing the product and service through market research. You wanted to find out what users thought about the product and why non-users haven't bought it. Japanese executives later adapted this into what's called the PDCA cycle. Plan, do, check, and act. All related to customer satisfaction. So as we look at plan, you're designing the product according to customer specifications, according to customer needs. Do is ensuring that production makes the product as designed. Again, focusing on the customer. Check, here you're checking sales, complaints, confirming whether the customer is satisfied. Acting, you're using feedback to incorporate improvements in the next phase of planning. So this became known as the Deming cycle. Deming reintroduced this during his management seminars in the 1980s and later changed check to study, calling it the PDSA cycle. So as we look at each phase, plan, do, study, act. Planning has a number of aspects to it. Defining the process, describing the key players, defining customer expectations, determining what data is available, describing perceived problems, identifying primary causes of problems, developing potential changes or solutions to the process, selecting the most promising solution. Again, focusing on customer needs. Do, conducting pilot studies or experiments, testing the impact of potential solutions, identifying measures to understand how any changes or solutions would be successful. In studying, you want to examine the results of the study, determine whether process performance has improved, identify further experimentation or studies that might be needed. In acting, you're selecting the best change or solution, you're developing your implementation plan, what needs to be done, standardizing it, establishing a process. So look at creative problem solving and what that includes. First, creativity is seeing things in new or different ways. And there's a process for creative problem solving. Understanding the quote-unquote mess. In other words, identifying symptoms that may be resulting in the problem. Finding facts. Identifying specific problems. Finding the root cause of that problem. Generating ideas or brainstorming. Developing solutions and implementing solutions. So first, the thing that's really important is understanding the difference between a symptom and a problem. So you might look at your business just as an example and say that, okay, well, our sales are decreasing, that's a problem. Well, not necessarily. The decrease in sales is more than likely a symptom of another problem. In other words, your decline in sales could be a symptom as a result of other things that may be happening. The problem, the actual root cause problem could be your customer service is terrible, which is resulting in less customers or customers leaving. Maybe the quality of your product has been deteriorating. Quality is bad. It could be a number of things in that sense, and that is resulting in your declining sales. So again, we want to uncover what the root cause is of the things that are happening to your business. We have custom improvement methodologies. FADE and DRIVE. FADE is focus, analyze, develop, and execute. DRIVE is defining the problem, recognizing the cause, identifying the solution, verifying the actions, and evaluating results. Park Place Lexus use this. I'll try to post a video for them as well. Here's the PDCA in a process improvement model. You can look through in terms of flowchart. DMAIC methodology. So again, these are different tools that businesses can use. DMAIC is define, measure, analyze, improve, and control. Now, Six Sigma is something that you may hear about a lot. What is it? It can best be described as a business improvement approach, and it seeks to find and eliminate causes of defects and errors in manufacturing, and also problems in service processes. Basically, it focuses on outputs that are critical to customers. It focuses on customer needs, and also financial return for the organization. The term Six Sigma is based on a statistical measure that equates to 3.4 or fewer errors or defects per million opportunities. So we use Six Sigma to refer to the statistical nature or statistical measure, and Six Sigma refer to the management philosophy. Bill Smith, who's a reliability engineer at Motorola, is credited with originating the concept in the mid-1980s and sold it to Motorola's CEO at the time, Robert Galvin. Smith noted that system failure rates were substantially higher than predicted by final product tests. He suggested several causes to it, including a higher system complexity that resulted in more opportunities for failure. So for example, you look at the article I shared about Harley-Davidson. Changes in technology have resulted in these motorcycles having a lot more technology in them than they have in the past, which you could argue that there's a lot more problems that could happen with these bikes now. And as the article went into, you're having failure rates in terms of recalls that are needed for things like hydraulic clutches or other new technology that's in the bikes that's failing. So again, as we look at Six Sigma approaches, it focuses on, again, fewer errors, fewer defects, fewer problems, given the number of opportunities that you may have. Now, the evolution of Six Sigma, as I mentioned, started out with Motorola in the mid-'80s, and then later on, former CEO Jack Welch of GE brought media attention to Six Sigma, made it a popular approach to quality improvement. In the mid-1990s, as quality emerged as a concern within GE, Welch invited Larry Bossidy, who was a CEO of Allied Signal at the time, who had a lot of success with Six Sigma, and wanted him to talk about it at a corporate executive council meeting. The meeting then caught the attention of GE managers, and Welch had stated, I just went nuts about Six Sigma and launched it. It was the most ambitious task the company had ever taken on. Again, something like this is a change in culture. Everybody has to buy in, and the entire company has to look at it. So again, the core philosophy of Six Sigma is based on the following concepts. You have to think in terms of key business processes and customer requirements with a clear focus on overall strategic objectives. Focus on corporate sponsors responsible for championing projects, support team activities. In other words, leaders in the business have to be visible. They have to serve as the champion to get things through. They have to really lead it. They just can't give lip service to it. Emphasize quantifiable measures, such as defects per million opportunities, that can be applied to all parts of an organization. Manufacturing, engineering, administrative, software, so on. It's not just specific to production. Ensure that appropriate metrics are identified early in the process, and they focus on business results. Providing extensive training, followed by project team deployment to improve profitability. Creating highly qualified process improvement experts. So Six Sigma, you can get certified as being a green belt, a black belt, a master black belt. And these are people who can apply improvement tools and lead teams. Also setting stretch objectives for improvement. So now Six Sigma is a bit different if we compare it to the older total quality management, or TQM philosophy, what our class is named after. Our class should be named quality management, or something a bit more general. TQM, the name is somewhat outdated. But in any case, some of the differences between Six Sigma and TQM, there's contrasting features between TQM and Six Sigma, and these include TQM is based largely on worker empowerment and teams, whereas Six Sigma is owned by business leader champions. You have key people in the organization that are really stepping up to lead this through, not just talking about it. TQM activities generally happen within a function, a process, or an individual workplace, whereas Six Sigma projects are truly cross-functional. So you're going to have more interaction across functional units. So you may have a representative from sales, marketing, engineering, design, whatever those organizations are, working together as opposed to just trying to make accounting more efficient. TQM training is generally limited to simple improvement tools and concepts, where Six Sigma focuses on more rigorous, advanced statistical methods and training methodologies. TQM is focused on improvement with little financial accountability, whereas Six Sigma does require a return on investment and does focus on bottom line. Now again, just some statistical basis of 3.4 defects per million opportunities. You have certain targets that you're living within. Example of calculating Six Sigma. We look at types of quality problems that companies may run into. All quality problem solving can be classified into these following five categories. Conformance problems. These are defined by unsatisfactory performance by a well-specified system. Users tend not to be happy with system outputs, such as quality or customer service levels. Traditional quality improvement tools in this area are used, and Six Sigma methods are often used here. Efficiency problems result from unsatisfactory performance from the standpoint of stakeholders other than customers. Examples here are cost and productivity issues. Lean tools are often used to address problems here. We'll talk about those. Unstructured performance problems result from unsatisfactory performance by a poorly specified system. That is, the task is non-standardized and not fully specified by procedures and requirements. Unstructured problems require more creative approaches to solving them. Product design problems involve designing new products that better satisfy user needs, the expectations of customers that matter most to them. For such problems, design for Six Sigma tools and methods are applicable, and we'll talk more about that in Chapter 12. Process design problems involve designing new processes or substantially revising existing processes. Challenge here is determining process requirements, generating new process alternatives, and linking these processes to customer needs. Work system design approaches discussed in Chapter 4 are typically used here. The projects, as mentioned, are the vehicles that are used to organize and implement Six Sigma. Although projects are set up as temporary organization structures, their flexibility allows cross-functional teams to complete significant work in minimum time, if they're well managed. One of the advantages, one of the challenges of implementing Six Sigma projects is to coordinate them with normal work activities. Six Sigma teams are comprised of several types of individuals: champions, master black belts, green belts, and team members. So as we look at the details, champions tend to understand the philosophy of Six Sigma. They select projects, set objectives, allocate resources, and select and mentor teams. Champions own Six Sigma projects, and they're responsible for their completion and results. Typically, they also own the process that the project is focused on improving. More importantly, champions work toward removing barriers, organizational, financial, personal, that might inhibit successful implementation of a Six Sigma project. Master Black Belts are highly trained in how to use Six Sigma tools and methods and provide advanced technical expertise. They work across the organization to develop and coach teams, conduct training, and lead change, but typically not members of Six Sigma project teams. Black Belts have advanced knowledge of tools and DMAIC methods and often act as project team leaders. They also mentor and develop Green Belts. Thus, Black Belts need good leadership and communication skills. As such, Black Belts are often targeted by the organization as future business leaders. Green Belts, typically one of the requirements for receiving a Green Belt designation is to successfully complete a Six Sigma project. Successful green belts are often promoted to black belts. Team members are individuals from various functional areas who support specific projects. They're expected to have subject matter expertise from the areas in which they arrive from. The factors that should be considered when selecting a Six Sigma project include the following. Financial return as measured by costs associated with quality and process performance, and impacts on revenue and market share, impacts on customers and organizational effectiveness, probability of success, impact on employees, fit to strategy, and competitive advantage. Competitive advantage is, what's going to set you apart from your competition? What is it you do really well? We talk about return on quality. What are the costs of quality, and we measure that against expected revenue gains. Again, everything is focusing here on the bottom line. So the efforts that you're putting in, the costs that are associated with it, what's going to be the payoff later? So the principles here that quality is an investment, efforts must be made financially accountable, and it is possible to spend too much on quality. You could end up with losses in the end. We talk about some, tools and techniques. As we look at defining, we define the problem in operational terms. We drill down to a specific problem statement. We'll look at what a Pareto analysis is, identifying the process using diagrams, developing a project charter. So a Pareto analysis can help identify the most important issue among a mess of symptoms. And Joseph Juran coined the term the Pareto principle and popularized it in 1950 after observing that a high proportion of quality issues resulted from only a few causes. He named this technique after Vilfredo Pareto. He was an Italian economist who determined that 85% of the wealth in Milan was owned by only 15% of the people. So Pareto analysis separates the vital view from the trivial many, I guess you could say, provides direction for selecting projects for improvement. Pareto distribution is one in which the characteristics observed are ordered from the largest frequency to the smallest. The Pareto diagram is a graphical description of a Pareto distribution. Pareto diagrams help analysts to progressively focus in on the most appropriate problems. The SIPOC diagram is a special high-level process map. So SIPOC stands for suppliers, inputs, process, outputs, customers. These maps provide a broad overview of the key elements in the process and help explain who is the process owner, how inputs are acquired, who the process serves, and how it adds value. Inputs are goods and services required by a process in order to generate its outputs. So in other words, raw materials needed to make a car. Or it could be what data is needed in order for you to generate a report. Outputs can be any physical items, could be documentation, could be electronic information, and so on. Inputs are provided by suppliers who may be external or internal to the organization. Suppliers may also be customers, for example, in a product design process. Customers are the people, departments, or organization that receive your output. They can be external or internal to the organization too. Different outputs may have different customers. So process mapping is an important tool. In defining a problem, it's important to have a very good understanding of the process that drives the results. And getting a visual representation is very important. So as we look at measuring, you focus on understanding process performance, collecting data that's needed. Key data collection questions. What questions are we trying to answer? What type of data will be needed? Where can we find the data? Who can provide the data? How can we collect the data with minimum effort or minimum chance of error? There's a number of different types of check sheets that are available too. There are special types of data collection forms which are useful because the results can be interpreted on the form directly without adding additional processing. Some types include check sheets used in manufacturing and are designed to create a histogram of continuous measurements. These check sheets could also include specification limits. A second type of check sheet for defective items shows the type of defect and a tally record. You could use this to include a time dimension so that data can be monitored and analyzed over time to look at trends and patterns. Another type is a defect location check sheet. You could use this to eliminate bubbles in laminated automobile windshield glass. Upon investigation, workers in one example discovered that the pressure applied in laminating was off balance and the right side was receiving less pressure. So the machine was calibrated, adjusted, and the formation of bubbles was eliminated almost completely. We look at analyzing problems, and you need to understand the process in order to do that as well. A special type of process map is called a value stream map. So the value stream refers to all activities involved in designing, producing, and delivering goods and services to customers. These activities include the flow of materials throughout the supply chain, transformation activities in the manufacturing or service delivery process, the flow of information needed to support those activities. Value stream map shows the process flows in a manner similar to an ordinary process map. However, the difference relies in the value stream maps highlight value added versus non-value added activities. So this aspect allows somebody to measure the impact of value added and non-value added activities on the process. So why defects, errors, or excessive variation happen? Well, there could be a lack of knowledge about how the process works. A lack of knowledge about how a process should work, including understanding what your customer expectations are. A lack of control of materials and equipment that's used, or just inadvertent errors in performing the work. It could also have waste and complexity. Hasty design, in other words, quickly putting something together. Failure to understand capability of a process, lack of training, poor instrument calibration, a number of things. When we talk about root cause analysis, we want to understand what the actual thing is that's causing the problem. What is the actual issue? So the goal of problem solving is to understand the causes of problems in order to correct them. Differentiating between symptoms and problems as well. As I mentioned, the idea of sales versus could be something that's impacting sales. So sales isn't necessarily a problem, it's a symptom of something else. So NCR Corporation came up with the definition of root cause as mentioned here, that condition or interrelated set of conditions having allowed or caused a defect to occur, which once corrected properly, permanently prevents recurrence of the defect in the same or subsequent product or service generated by the process. So, with a medical analogy, eliminating symptoms of problems usually provides only temporary relief. Eliminating root causes provides long-term relief. So you could try to boost sales with lowering your price or providing some type of promotion, buy one, get one free. But again, that's just dealing with the symptom, right? You could just look at your customer service or the quality of your products or whatever it may be that's causing the low of sales to begin with. We can look at cause and effect diagrams that can be used to find out what problems are and look at symptoms as well. Brainstorming is another tool. You want to generate as many ideas as possible. So it's pretty useful in group problem solving for generating ideas. And it was proposed by a person by the name of Alex Osborne for the sole purpose of producing checklists of ideas that can be used in developing a solution to a problem. So with brainstorming, there's no criticism that's permitted. People are encouraged to generate a large number of ideas, whatever they may be. Wild ideas are encouraged because those are going to trigger other ideas. We look at control, you're maintaining the improvements. You want to put tools in place to make sure that things maintain or remain within acceptable ranges. So you establish new standards and procedures, you train your workforce, you put checklists in place. Lean tools. So as we talk about lean production, lean tools, this is something that originated in with Ford Motor Company in the early 1900s, but it was refined and modernized by Toyota later on. Lean approaches focus on the elimination of waste in all forms, including defects requiring rework of something, or unnecessary processing steps, or unnecessary movement of materials or people, trying to eliminate waiting time, excess inventory, try to eliminate overproduction. A simple way of defining it is, quote-unquote, getting more done with less. It involves identifying and eliminating non-value-added activities throughout the entire value chain. You want to achieve faster customer response, reduced inventories, higher quality, better human resources. So we have tools of lean production, which are listed here. We have the 5 S's, which are derived from Japanese terms siri, which means sort, seton, set in order, saiso, shine, seek, etsu, standardize, shisuki, sustain. They define a system for workplace organization and standardization. So sort would refer to that, or refers to ensuring that each item in a workplace is in its proper place or identified as unnecessary or removed. Set in order means to arrange materials and equipment so that they're easy to find and use. Shine refers to a clean work area. Not only is this important for safety, but as a work area is clean, maintenance problems such as oil leaks can be identified before they cause problems. Standardize means to formalize procedures and practices to create consistency in the way things are done. That way, make sure all steps are performed correctly. Finally, sustain means to keep the process going through training, communication, and organizational structures. You also have visual controls, efficient layout, standardized work. Visual controls are indicators for tools, parts, and production activities. They are placed in plain sight of all workers so that everyone can understand the status of a system at a glance. If a machine goes down or a part is defective or delayed, immediate action can be taken. Efficient layout, standardized work, the layout of your equipment and the process designed. Standardizing individual tasks by clearly specifying the proper method reduces wasted human movement and energy. Pull production. In this system, also known as Kanban or just-in-time, upstream suppliers do not produce until the downstream customer signals a need for parts. Single-minute exchange of dies, SMED, refers to rapid changeover of tooling and fixtures in machine shops so that multiple products in smaller batches can be run on the same equipment. It reduces setup time. Total productive maintenance is designed to ensure that equipment is operational and available when it's needed. Source inspection, inspection control by process operators, guarantees that a product passed on to the next production stage conforms to specs. And continuous improvement provides a link to Six Sigma. In order to make lean production work, You have to get to the root causes of problems and permanently remove them. Teamwork is especially important in lean environments. Lean Six Sigma, again, a more integrated improvement approach to improve goods and services. You want to eliminate waste. You want to eliminate or reduce defects and variation. You have metrics and services in terms of accuracy, cycle time, cost, and customer satisfaction. These are the things you'd be measuring in Lean Six Sigma applied to services or a service business. Think of a call center or something like that.